Welcome, everyone. We are delighted to have you all today for Marine Materials, Designing the Future with the Ocean. My name is Luam Malake, and I am Senior Researcher at the Healthy Materials Lab and the Dongia Healthier Materials Library at Parsons School of Design in New York City. For those of you who are new to our work, Healthy Materials Lab is a design-led research lab at Parsons School of Design. We are dedicated to placing people's health and environmental health at the center of all design decisions. In practice, that means we raise awareness about toxics in our built environment and work to make healthier materials and strategies more accessible by creating free resources, like this event. Our mission is to transform all lives to be healthier with a focus on affordable housing as a first step. At HML, we understand that change begins when we ask questions, have conversations with experts from a variety of disciplines, and question assumptions about conventional design practices. Scientists, researchers, and material innovators are leading the way towards a petroleum-free future, in part through the responsible care and use of living marine resources. The health of the ocean is essential to all life on Earth. Oceans play a critical role in regulating our climate and weather patterns and provide a wide range of food and medicinal ingredients, and of course are home to countless species. However, our reliance on fossil fuels is threatening the health of our world's oceans. Carbon emissions increase ocean temperatures and acid levels, and pollutants such as microplastics threaten marine biodiversity as well as human health and safety. Oceans also offer a variety of rapidly renewable resources that can support a petroleum-free future for design, such as eelgrass, algae, and seaweed, which together represent an exciting frontier for material science. Material innovators are discovering the potential for these resources to replace harmful fossil fuel-based plastics with healthy, carbon-sequestering, biodegradable materials. We have been looking forward to learning from our guest speakers. Today, we will hear from two research-based manufacturers of innovative products derived from eelgrass and kelp, forefronted by a broad look at oceans by a marine research scientist specializing in microplastics and remediation. She is also an oyster and seaweed farmer. And I will go ahead and introduce her. Her name is Abby Barrows. Abby Barrows is a marine scientist, researcher, and oyster farmer, and has been at the forefront of global microplastics pollution research since 2013. Abby received a Bachelor of Science from the University of Tasmania and a Master of Philosophy and Human Ecology from the College of the Atlantic. She has since built the most extensive and diverse data set on microplastics available to date, shaping international understanding and action on plastic waste in marine environments. Beyond research, Abby is a hands-on field scientist and educator committed to raising awareness about plastic pollution and advocating for sustainable solutions. She is currently reimagining the future of aquaculture by designing and developing plastic-free gear for oyster and seaweed cultivation, paving the way for a cleaner, more sustainable future for our oceans. Tobias Årstrom, who I'll introduce next, is co-founder and head of research and development, design, and creative direction of seaweed, a Danish company pioneering the use of eelgrass as a building material. Originally trained as an engineer and architect, Tobias has a decade of experience as a project architect at high-end Danish design studios, where he gained broad technical knowledge and an understanding of designers' priorities. He ensures Seaweed's eelgrass products are buildable with high design and materiality standards, and has driven the company's material development since its founding. With his strong sense of design and materiality, Tobias controls the creative direction of Seaweed and oversees the strategic collaborations that Seaweed enters into. Most recently, Seaweed has embarked on an international collaboration with Spinneybeck by Miller-Knoll. Next, I'll introduce Celine Sandberg. Celine is founder and CEO of Agroprene, a startup on a mission to reinvent furniture foam using seaweed and natural materials, including crab shells and eggshells. Born from a mix of entrepreneurial curiosity and a drive for sustainability, Celine's journey started in a small kitchen, experimenting with seaweed during her studies at the Norwegian University of Science and Technology. With no intention of following the typical tech startup path, She embraced the challenge of tackling foam, a material responsible for millions of tons of CO2 emissions annually. Thank you all so much for being here. But before we dive in, a few housekeeping notes for our attendees. The Q&A is open, so please feel free to jot down your questions in the question box at the bottom of your screen. If you see that someone else has asked a question that you like, give it a thumbs up to push it up to the top of the queue. Please use the Q&A for questions instead of the chat box. Questions that are in the chat box will not be added to the queue, so make sure you're opening that. Abby Barrows, thank you for being here. I will hand it over to you.
All right. Thank you again for everyone and their interest in logging in the middle of the day on a Tuesday. I'm going to talk about microplastics and briefly touch on some of my microplastics research, and also talk about what I'm currently working on with alternative materials in the aquaculture industry. So, microplastics. They are a pollutant that has emerged as an issue of international concern. 10 years ago, almost no one knew about them. Now it's a household name. They are defined as a piece of plastic between 1 micron and 5 millimeters in size. And it's really important to think of microplastics as a suite or a class of contaminants. Microplastics are diverse. They come from many different products and polymer types that have the shared characteristics of being non-biodegradable. They absorb and release chemicals. They fragment, but they don't disappear. And they come in different shapes, sizes, and colors, with microfibers being the most commonly found in our environment. Microplastics have unfortunately been found in all of the world's oceans, from the surface to the deep ocean trenches, in freshwater environments, tap water, bottled water, all sorts of different beverages, our agricultural soils, honey, table salt, seafood, birds, human placentas, breast milk, testicles, our brains, and our air. The more places we look, the more places we find this pollutant. So unfortunately, when plastics are consumed either directly out of the environment or indirectly through consuming prey that contains plastic, the toxicants from and on plastic can leach into the animal and find a permanent place in the food web. We have also discovered that microplastics and nanoplastics can move through the blood membrane barrier and enter into different body systems. Studies have shown associated behavior changes, reduced reproduction, energy uptake, and diminished offspring performance in animals that have ingested microplastic. Ingestion could have long-term individual, population, and community-level impacts that we're still just beginning to understand. Ultimately, this is concerning because we don't know what the long-term effects of ingesting microplastics and their associated additives are on either human or animal health. So about a decade ago, I did a microplastic ingestion study at the Shaw Institute here in Maine. We analyzed seafood. We looked at mussels, both rope grown and wild caught, oysters, clams, lobsters, and mackerel. We found microplastics in 96% of these seafood samples. The average number of microplastics we found per gram of tissue was 2.5 pieces. So although microplastics research has been a very fast-moving field, there continues to be a lot of questions. Although we do have a pretty good understanding of residence times of plastic in filter feeders, it looks like they are able to pass it out, depurate it out of their bodies completely over a range of days. The concerning thing is that the additives stay behind. So it was this study that drove me to want to ask bigger questions about microplastic distribution. I approached and partnered with Adventure Scientists, which is a nonprofit organization based in Bozeman, Montana. They strive to solve some of the world's most pressing environmental challenges, in which access to physical data is crucial to finding and implementing solutions. We launched the Global Microplastics Initiative. They primarily managed the citizen scientists, and I ran all other aspects of the project. So after 5 years, we had collected thousands of samples from all the world's oceans and all of our continents. And this is a map that shows all those data points. At each of these points, a 1 liter surface grab sample was collected by an adventure scientist. The size of the bubble is indicative of the quantity of plastic. So larger bubbles, more plastic were found in that sample. The color indicates presence, absence of plastic. So the yellow bubbles were samples that contained no plastic. We collected about 2,500 usable samples. About 1,400 of those were in the marine environment, and we found an average of 12 pieces of plastic per liter of seawater. We collected just over 1,000 freshwater samples with an average of 1.3 liters microplastics per liter of water. 90% of the plastics that we quantified were microfibers. The majority of those were invisible to the naked eye, so less than 1.5 millimeters in size, which is a smaller size than those captured in the majority of surface studies. The marine results show that the microplastic concentration is higher in the open ocean than in coastal environments, with the highest concentrations found in the polar oceans. This has further been validated by many other studies. One other thing to note is that the samples are very spatially diverse, and that is due to the small sample size of 1 liter. Okay, so changing gears. So while all this global research was going on, I was running a lab and spending a lot of time on the microscope. I had the opportunity to buy an oyster farm in this cove, Long Cove in Deer Isle, Maine. And after a few years with a really sharp learning curve, as I had no business background or aquaculture background, I began to integrate my passion for reducing plastic pollution into research and development on oyster farm cultivation gear. I was attracted to oyster and seaweed aquaculture because they tread relatively lightly on the environment compared to other types of aquaculture, fisheries, and food systems. And undoubtedly, the species cultivated are beneficial to local ocean health in many ways, which the industry likes to promote pretty shamelessly. But it's true. Oysters and seaweed do provide an impressive list of ecosystem services that are really important for our waters. So, for example, carbon sequestration in seaweed. Adult oysters can filter up to 50 gallons of water in a day, and that can dramatically increase the water clarity and in turn the water quality. Discarded oyster shells directly combat localized ocean acidification. Oyster reefs and oyster farms provide habitat and protect the coast from storm surges and help reduce coastal erosion. Also, eating oysters are delicious, and seaweed, but they're also a responsible source of protein and nutrients. But the fact remains that a reliance on plastics in every step of cultivation can have lasting negative environmental impacts. Every step of plastic production, from extraction, use to disposal, contributes to greenhouse gas emissions. Plastic was never designed to be recycled. It's still not designed to be recycled. All plastic eventually fragments into microplastics. And it's projected that we will more than double our plastic production by 2050, producing approximately 884 million tons. All of that plastic has the same end of life, whether it's been recycled a couple times or not. It is landfilled, burned, or lost to the environment. So I'm going to talk a little bit about my R&D, but first I want to take a step back so we can all be on the same page. So here in Maine, we mostly rely on surface cultivation for oysters. The gear types generally fall into 2 categories. We have the single bag, which is on the right-hand side, and that's generally used in smaller farms. And that's a plastic mesh folded into a rectangular box, floats are zip tied on. So there's some variation, but the concept and the design is the same. Often these bags are closed with a synthetic shock cord. These bags take up a fair amount of real estate, but they're lightweight and easy for one person to handle, as you can see in the photo there. The ranch system is a infrastructure with large plastic floats that you slide bags into. So they're typically 4 or 6 bags or boxes, as you can see here. They're often closed with a synthetic shock cord or clips. These maximize farm space though, but they're heavy and you need some people or infrastructure to handle and flip them. The other thing to note is that they use these floats that have threaded caps you take these caps off and let the floats fill with water to overwinter the farm and sink that down to the ocean floor. So in 2021, I was awarded funding for a small project to look at alternatives to plastic and oyster gear. Again, I was not trying to reinvent how we grow oysters, just what materials we use to grow oysters. My farm came with single bags and a handful of ranches, so we first started with materials to replace the single bag design. We started to scratch the surface, identifying durable yet ecologically friendly materials for aquaculture systems. And at the most basic level, our goal was to figure out what materials were best for the job in performance, supply, and scalability, and that met our ecological goals. Turns out 1 year is not enough time to do that at all. We also were a little bit limited. We worked with only a handful of materials, partially because we're still in the pandemic and we had a lot of supply chain issues and also high costs. So we really focused on fine baby-sized mesh bags using stainless steel and aluminum window screen and basalt mesh. As you can see in the top right-hand corner, there's actually a big tear in that basalt mesh from a bird landing on it. And we also played with flotation, cork flotation in particular. We found that the cedar boxes were buoyant enough in themselves that they didn't actually need the cork flotation. It was a great start. We learned a lot about what didn't work and what we didn't want to use in terms of materials. And it was clear to me that we needed a lot more time, trials, and resources for this project. Luckily, I was able to receive more funding and expand our material trials and project scope with the similar goal. We also expanded our collaboration with partner farms. We did side-by-side trials with plastic and non-plastic gear to compare oyster growth. No significant difference. Additionally, we collected bi-monthly abiotic data, so temperature and salinity, because the environmental pressures are very different along the coast of Maine. And we also collected information on how the gear handled and held up using a basic rating system. At that point, we're still really focused on the single bag. We were playing with stainless steel metal, larger mesh sizes, natural rubber, manila rope to hold things together. And with the flotation, we were still playing around with cork, but we connected with a woman named Sue Van Hook, who had co-founded Ecovative, a mycelium company in New York. And she grew and taught us how to grow mushroom or myco buoys on hemp chaff. So we played with a lot of different coatings for this type of flotation, the myco buoys. And that video is showing us painting on some linseed onto a myco buoy. We also used pine tar. We played with mineral finishes derived from crushed up oyster shells. We used aerogel, nanocellulose, water-resistant algal-based coating, and none of it really worked. So we had a lot of learning experiences. We also had a lot of gear loss. We did some involuntary seeding of the cove of oysters, and we learned a lot about materials in salt water. So in 2023, we expanded our prototypes to be better compatible with farms configured to ranch culture. And we took all those failures and were able to really drive those into this design. So we started using 4-bay and 6-bay aluminum ranches or grow cages with different types of floats. So on the left, there's a cork with a linseed paint, and on the right is a myco buoy with a soy-based marine paint that was designed specifically for the myco buoys. So we continue to work with Sue Van Hook, and we also continue to refine our bags. They're still a bit clunky and heavy, especially after being in the water for a few months. We also started to play more with welding in our shop. Here is just some pictures of more prototypes. We have cedar boxes here in the middle with perforated aluminum. We have basalt mesh down here. We've started to play a little bit more with how to stretch that and make it a little bit more robust. And reduce the amount of wood in some of our designs because it was causing flotation sort of wonkiness of bags. And we also started to play with more coatings, again, for the different flotation types. So we have a rubber mastic here, more linseed paint. Unfortunately, that was really not scalable. This lath wood that actually swelled up and created a barrel-like flotation. Overall, we had much higher success in gear robustness and workability, which helped us hone our design for last season. So in 2024, we started to incorporate more metal, and we were able to get the ranches to sit in the water a lot better while drying, which is essential. You really need that water flow for healthy oysters. We worked on having less wood in the smaller boxes, so they'd be less cumbersome and not float so much that it pushed the oysters out of the water. And we also started working with some Canadian farmers that produce the 6-bay aluminum ranches. We still have a lot more testing to work out the kinks and make it easier and lighter to handle and completely interchangeable with traditional ranch systems. Metal and salt water and corrosion in the electrolysis of even marine grade stainless steel has been a challenge, but we've been playing with anodes to reduce that electrolysis over time and trying to figure out how to have either all the same type of metal or have more buffers around those metals. The micro buoys, a lot of them made it through the season, but and I really want to have something that's more robust and can last seasons of season. But that's always the trick, right? With having something that's biodegradable, but not last forever, but you want something in between. So we'll continue to play with learning from those failures. So we have had a lot of things just utterly fail out there as well. And that's something that just helps inform our next steps. This winter and next season, we've been very focused on the flotation. We're still working with the micro buoys and that have some different biocoatings and working with Narid Biomaterials, who's doing a PHB bioplastic, which is made from utilizing waste methane gas from wastewater treatment plants. So we'll see how that goes. I've also been leaning on my networks and opening it up to the room to maybe help find or develop a non-toxic coating that we could use both on flotation, the micro buoys, and also coat our metal to help with that electrolysis reduction and longevity in the water. The other exciting thing that I've been designing is flotation for those ranches. Remember those large pontoons that have the threaded ends? We want to mimic those, but use a aluminum pontoon style buoy. And we're having those prototyped as we speak. So we learned that R&D in the marine environment is a multi-year process. But we've been able to produce a ranch using about $300 worth of materials, which is comparable to that is what's on the market right now. And we've also grown some fine oysters in the meantime. So looking forward, we were just granted another 4-acre standard lease in Deer Isle, Maine, and we plan to build that from the ground up as a plastic-free farm. I really want to model what that could look like on a commercial scale for both oysters and seaweed. We're hoping to continue to expand upon our baseline research in building gear and integrate natural materials into sea vegetable farming, and hopefully with the help of a recently developed all-natural wool and algal twine from Viable Gear Company here in Maine. We also hope to have open source gear design available by the end of next winter and potentially be in the position to take orders from other farms interested in migrating to or starting with plastic-free gear. We want to work towards having plastic-free gear be a real financial and workable option for sea farmers. We also continue to move away from plastic in other aspects of our business and existing on the water infrastructure, from using metal boats. We're having one built right now and that will launch in a few weeks without any bottom paint on it, as well as moving to store oysters in wooden crates. And we're using a company called Ocean Farm Supply that produces a home compostable beechwood bag for selling our oysters. We still have a lot of hurdles, but in the future, we want to see plastic use for growing sea products as the exception and not the rule. My vision is to continue to pursue disruptive innovation to help change the materials approach to aquaculture, creating a truly sustainable food cultivation system. Because I think as farmers and as stewards, we can do better. Thank you so much, everyone, for listening. And I will now hand it off to Tobias.
Thank you. And I will just share my screen here. So thank you for having me here. I'll just tell you a little bit about eelgrass. So here at Seaweed we're doing acoustic products made out of eelgrass. And so eelgrass is a amazing plant that comes from the sea. So for the last 9 years, I've been working to develop a product that can be used in the build industry, but also in the design industry. So initially, the idea was to have a material that could be one-to-one replacement for existing products on the market. So in the insulating market, for example, there's a lot of mineral wool, for example, that really performs well according to performance. But on the same, let's say, page, you have a lot of sustainable materials that are amazing in a way of sustainability, but they really have the lack of performance. So the mission from the beginning here at Seoul was to create some kind of bridge in between sustainability and performance. And hopefully I can show you how eelgrass could be the potential bridge in between those two. So firstly, I will describe a little bit what is eelgrass. So hopefully here on the screen, you can see a small boat and the small ocean here in Denmark. So eelgrass is actually a plant. It's not an algae like seaweed. So it needs the light to grow. And while it's growing, it's absorbing enormous amount of carbon in the plant. And eelgrass, because it's a plant, it also has a cycle. So over the season, the leaves from the plant is getting released, and then they end up on the beach. So here on the picture, you can see that the leaves are stranded on the beach, and then basically you can pick it up and use it. So it's already a waste product from the nature. So we're not harvesting anything. We are basically just collecting what is left from the nature. And at the same time, by taking the eelgrass, we are also taking nutrients out of the sea. So, for example, here in Denmark, we have a big problem of too much nutrients in the sea because we have a lot of let's say farmers farming and let's say they're getting polluting let's say ingredients into the sea and adding more nutrients. So by actually taking the eelgrass away from the beach, we can actually store the nutrients as well. So eelgrass is an enormous storage of CO2 potentially, and it's really a robust material. So here in Denmark, we actually have a long tradition of using eelgrass for the roofing. So for centuries here in Denmark, we have been using eelgrass for replacement of straw. We have a small island called Læsø, where they have for centuries been using this typically tradition of thatching with eelgrass because there was a scarcity of other materials. So the straw was not existing at the island, and the men was out sailing. So it was actually the woman who was inventing this kind of procedure of taking the eelgrass and putting on the rafters on the roof structure and creating this enormous and quite of a heavy looking roof. But the time was showing that it was really a long lasting material that can last for centuries. The material couldn't burn because it comes from the sea, so it's already impregnated with salt. And it was insulating really good, and small animals or anything didn't want to live in it. At the same time, we also had to use enormous amount of material. So that's the bridge. And so we are trying to have the same properties as the old roofs here in Denmark, but putting into a more modern form. So basically what we have been creating is a sound panel, a sound acoustic panel that is our sound absorbing. And we have been getting the highest classification on the acoustic level. At the same time, on the fireproofing, we have gained the highest fireproofing because eelgrass is coming from the sea. So it's already impregnated with natural fire retardant. So we can actually gain the highest class. So in the States, for example, we are class A. So on the same level as the best performative material. And because we have been solving number 1 and 2, we can actually start to talk about carbon storing. Because if your product is not scalable, then you can never talk about the carbon storing. So this is really crucial for us. So our product is obviously a natural, so it has a big carbon sink. So our product is sort of CO2 negative. I'll come back to that. And then as you can see on the roofing, it's a really robust and durable material. So something you can also recycle again and again. And because it's coming from the nature, you all have all the benefits like wood is moisture regulating. It can also regulate the heat. We don't have any emission at all in our material. And the character of number 7 is a natural character. I think that's also really keen in the modern world, that you build your houses of some material that you have no idea where it's coming from. For example, mineral wool, you have no idea that it's used to be a stone or glass. But here we have such a natural presence in the fibers and in the surface. So that has been really keen for us to not just destroy the surface and not just having a brown surface, but actually having the natural fibers present. So the way we are producing is we're taking the eelgrass while it's quite fresh on the beach. Then we put it on grass fields, like you do with hay. Then we wait for the sun and for the rain to come to wash the eelgrass. Then you rebale it like you do with hay. And then we put it into a modern production here in Denmark, where we shred it, we handle the fibers, we first make a very thick mat, which we later on are compressing into acoustic panels. Then, of course, in the whole process, we are checking that everything is up to standard. So this procedure is actually making sure that our carbon footprint is negative when we deliver our, let's say, product to the customer. So this means that eelgrass actually absorbs more CO2 in the process of its living compared to the CO2 that has been used in a production. So compared to traditional material, we actually in the negative space. That is in a positive way. We are using less CO2 in the production than we actually sequestering. So that's the way building material or design material should be. And at the same time, we also are making sure that we can recycle our material. So for example, this on the left, you can see a construction site here in Denmark where our material has been used for the full ceiling at a restaurant at IKEA. And afterwards, all the offcut from the construction site is sent back to us. So basically, our idea about the material is that it should last as long as the roofs at Læsø in Denmark. So up to 300 years, the cycle of the material should be. We don't want to have our material in the forest or in the sea or anything. It should come back to us so we can recycle it. So according to the performance, here you can see a graph where we actually perform better than most of the existing material. If you look at cork, we actually 4 times better according to the acoustics, and wood cement and textile and so on. And according to fire, this is also quite critical. Now we've reached the highest fire standard in the United States and in Canada, but also in Europe here we have systems now where we can use in a full-scale system. And this has always been a problem with bio-based materials because we always need to put so much chemicals into the products to make it work. Then we are cradle certified on the highest level on health, on platinum level. So there's nothing toxic in products. And because we have been developing a product from more or less from scratch, even though the roofing on this has been there for many years, we have been going through quite a lot of certifications to actually prove that our materials is performing. And we are still in this journey of, let's say, learning our customer, but also architects around the world that this could be a replacement for mineral wool. It could be, and the ceiling doesn't have to be white and white. It could also actually be brown and natural. So this is something that needs to be certified and something that you need to have the right stamp on it. And this is something where we have been working for many years to achieve. So now we've been a little bit into the products, but now in the end, I want to show you how it has been used and maybe also showcase maybe also how, let's say, the new contemporary, let's say, architects are working with natural material, because we are also trying to give some kind of guidance how to use our material, but also how you can fulfill, let's say, a modern, let's say, way of using natural material. So we are doing quite a lot of retail projects, residential, cafes, and restaurants. And here first is some ceiling projects. So this is at a house in Denmark, a private villa, where they've been using our material on the full ceiling, together with solid woods and other local materials from Denmark. Here you can see actually, even though it's a brown and quite dark material, it actually emphasizes actually, let's say, making a nice contrast to the normal materials and actually making a beautiful roof. And this is this more or less the same, let's say, project, but in a different site. But we have two products, one that is quite high density, this is this one, and then the other one was a low density. This is the high density where you can see that it's more sharp, you can make sharp edges and you can make chamferless edges. This is the IKEA where you saw from the construction site. So this is a more normal SA project, but this is also showing that in a big scale projects, it can be used. And also together with other colors, it also works quite well to have, let's say, a brown ceiling. Then it's also one of the typical ways to use the material is also together with in restaurants, for example, as wall absorbents. So this is from Kyoto in Japan, where it has been used at the famous restaurant of Noma as a wall absorbent. So the main acoustic elements in the restaurant, but also showcasing that there's also something about the storytelling of showcasing the natural fibers from the sea and combining with the high-end dining. With this season, all the ingredients was coming from the sea. That was a nice story. And here as a bended element around the bar, but also as a sound absorbent element. At Hotel Marriott, it has been using here in Copenhagen to highlight the tactility of the material, but also making a more contemporary context with integrated light and cassettes of wood. Small projects where it's integrated in the gable, and also giving some depth into a room where it's quite bright and quite bleach colors. This is a museum in Denmark where it has been used from video artists has been showing it, the material on the walls. So this is a video artist work. And we're also been working with some wooden lamellas to also see how is the material working together with wood, and how we make different kind of systems where you can also even improve the fire rating by using wooden lamellas in different configurations here. Then we also have our own design solutions, just to showcase what is actually the design features of the materials. So this is our specially made wooden joints, where it's emphasizing that our material is actually a soft material. So the small joint is pressing on the material, so you can see the small bend in the material. So emphasizing that it's not just a surface; it's actually I'd say a solid material that has a certain depth. This is a modular system. You can just extend as you want, and then there's no glue or anything. You can just actually demount it and replace it. So it's 100% designed for disassembly. Then we also have designed a frame, which is quite simple, but you can frame the material and combine it with wood. So it frames the material quite, let's say, simple, and it's an easy way to understand the material together with another natural material. Then, as a more local thing in the United States, we have been have made a joint venture together with Spinnebeck, which is part of Millenol, and they have been designing this baffle, which they have now been showcasing with our material. And here you can really see, let's say, the core tactility of the material when it's used as baffle, that it can be suspended from the ceiling. So this is something we're quite happy to see. So that's our small journey in Seoul. So basically, we have been trying to develop a unique material that comes from a long legacy here in Denmark of using eelgrass as a roofing material, but trying to make it into a more modern way to use it. And also, we have been putting quite, let's say, much energy into the design of the products to actually showcase this is not something that only belongs into eco villages or anything. It can actually be a high-end material that comes from nature, which can be 100% compatible according to performance and acoustics and fire. So we hope you are going to use the material one day. So now it's also available in the States. So yeah, thank you for the time. And now I will send it over to Celine.
Thank you. Let's see. Yes, I will just. There we are. Hi, everyone. I am Celine, joining you from Norway. And I have to say, I'm very excited to be here today. I am the founder of Agoprine, a company that I started almost 5 years ago now, during my master's degree. And honestly, I never planned to end up in the foam industry, but here we are. So, what is Agoprine? In simple terms, we are on a mission to reduce the reliance on petroleum-based foam in the furniture industry. And I get it, foam is not something most people think about. I certainly didn't until I started this company. Because most people don't know this, but almost all furniture foam today is made from petroleum. That means we sleep on oil every night, we sit on it, and we fill our homes with it. And we don't even talk about it. The problem is that it takes a huge amount of energy to produce it. It emits tons of CO2, and worst of all, it is almost impossible to recycle. When something can't be recycled, the only option we have is to burn it. And when we burn it, all that stored carbon is released straight back into the atmosphere. But how much waste are we actually talking about? Finding data on global furniture waste is nearly impossible. But here's what I found. In Europe alone, 40 million mattresses ends up in landfill every single year. And this is only mattresses. That is a huge number. And if we were to stack all these mattresses on top of each other, they will correspond to 904 times the height of Mount Everest. And I just want to bring up a short story about this. Because a few months ago, we were showcasing our foam when a man stopped and thanked us for the work we're doing. He was the first person that I've ever met that thanked us like that. And the reason he did is something that I will never forget. Because he told us that a lot of the foam waste from Europe ends up in his home country, Nigeria. When the rainy season hits, the foam floats the streets, and there's so much of it that you can't even see the ground. It's like walking on a sea of foam. And people have no choices than to step on it because it's everywhere. And we don't see this in Europe. And it's very easy to close our eyes to it. And it's very easy for me to talk about the numbers. But hearing his story was different. It isn't just a number or something I bring up in like a startup pitch. It's very real. And this might be the reason why companies like IKEA has committed to replace all petroleum-based foams by 2030. The problem is that they don't have any good alternatives. Until now, of course. Agoprine is helping the furniture industry by offering furniture foam made from seaweed, a fast-growing, untapped, and sustainable resource from the sea. Seaweed is our main ingredient, but we also mix in natural minerals and other plant-based materials. Our foam is, of course, completely free of petroleum, and it will naturally degrade in soil. We also have a patent pending, and I'm very proud to say that this is the first of its kind. I know what some of you are thinking. Sure, it's sustainable and all that, but is it actually good? Well, The furniture industry is known for having the world's strictest quality standards. But we have decided to test against the highest standards anyways. And we passed all of them. So this means that we can say that our foam is built to last for at least 20 years of use. It's naturally flame resistant, unlike petroleum and latex foams, which are highly flammable. It can be recycled into new foam. And we're currently undergoing testing for compostability, which are looking very promising so far. While many startup stories start in a garage, our story started in a student kitchen in Norway in 2020. We had no funding, no experience with seaweed or biomaterials in general. I would say we had some passion, a lot of fun, and a kitchen full of experiments that definitely were not eatable. Since then, we have built our own pilot production facility, and we have produced over 1,500 kilos of foam. In 2023, our story got picked up by Wired, BBC News, and World Economic Forum. And this resulted in over 400 companies contacting us from across the globe, all of them looking for alternatives to petroleum-based foam. Our foam has been on the market since 2024, and people are sitting on Agroprime foam on a daily basis. We mainly sell our foam for seating applications for office buildings, mainly because of our limitations in production. Right now, we are focused on scaling up. We are building an automated production line to meet demand. And as we grow, we're also figuring out how to do it in a way that makes sense for both the planet and the resources that we have. Because, let's be honest, no company is perfect, but we take our choices seriously. What I mean by that, we work closely with our suppliers. All of them are based in Norway. We use waste streams for raw materials when we can. And we're working towards a circular system where the goal is to turn old foam into new foam instead of letting it go to waste. While I can't show you our new production line just yet, I can show you how we've been making foam by hand up until now. And figuring out this process has probably been our biggest challenge. Petroleum foam is, simply said, made by mixing two chemicals that react and create gas, foaming bubbles, and just like that, you have foam. But our process is completely different, and it doesn't rely on the same chemical reaction. And it takes more than 2 ingredients. So yeah, I like to think about our process as more like a baking process than a chemistry process. In fact, our whole setup is inspired more by the food industry than the chemical industry. And here is how it works. So we start with powders, our raw ingredients. We mix them together in a specific order while controlling the temperature. Then we pour the mixture into molds. And finally, we bake it, just like a loaf of bread, until it turns into our finished product. It's simple when I explain it like this, but trust me, getting it right, it took some years of trying and failing. It's also been a lot of hard work and a couple of back pains, making one cushion at a time like this. I am grateful that we have had a lot of fun along the way, because there's nothing that is easy about building a material startup. And the biggest challenge is that petroleum-based foam has had 80 years of research, development, and scaling. It is a trusted material in the industry. And our foam can't be just plug and play into an existing petroleum foam factory. Everything we do, from developing the material to engineering the production line and setting up the value chain, it needs to be built from scratch. That's the real challenge. It doesn't mean that it's impossible. It just means that it's going to take some time to get there. And on top of that, we are working with seaweed, which is still a relatively small industry when you compare it to petroleum. It is growing, but it's still not established. So while we are excited about the potential, we also have to be creative with how we source it, process it. And we will do our best to make things as sustainable as possible. Because I believe when seaweed is used correctly, it's an incredible resource. It requires no land. It can be harvested sustainably without harming marine ecosystem, and is naturally fire resistant and biodegradable. But most importantly, it captures and stores carbon. Seaweed is one of the fastest growing plants on Earth, capturing large amounts of CO2 as it grows. But what happens next matters. If we just burn it for biofuel, eat it for sushi, or use it as a fertilizer, that carbon is released right back into the air. I believe a better solution is to lock that carbon away in durable materials. Materials that will last and can be recycled, not just single-use ones. So by turning seaweed into materials like furniture foam, we store CO2 for decades while replacing petroleum-based materials at the same time. And that's part of the reason why we ask ourselves some pretty big questions while we move forward. And one of them is there enough seaweed to replace all petroleum-based foam? The short answer is no. And that's okay. Because replacing petroleum with just one alternative is not the solution. The real solution is diversity, thousands of sources, not just one. I am actually dreaming about a world where you can walk into a furniture store and choose if you want your mattress to be made of seaweed, cellulose, oysters, mycelium, banana fibers, coffee grounds, or any other cool sustainable material. And that's probably why I'm not trying to get more companies to make foam from seaweed. I'm here because I think we need to rethink the material industry. And I think the ocean holds some of the answer, but not all of them. So that's Agoprene. We're not here to be the only solution. We're here to be a part of the solution. Thank you.
That was fantastic. Amazing to hear from all of these fantastic experts. Thank you all so much for your participation. We have a lot of questions in the Q&A, and I'd like to remind the audience, the attendees, to upvote any questions that you would like to hear answered, and also to add your own questions there if you have any other questions. But before we get to the audience questions, I'd like to open the floor to our speakers and see if our speakers have any questions for each other. And, you know, it's optional. Feel free if you have one. Yes, feel free to speak. If not, we can move on to some other questions. I think I wanted to ask one question and that I think kind of covers a lot of the questions the audience are asking. And this is more for Tobias and Celine. But how do you imagine scaling up your work and like what the ecological or practical challenges might be in order to do that? Or do you imagine scaling up your work, or how far do you imagine taking this? So that's both for Celine and Tobias primarily. But if Abby, you have an answer to that, feel free.
Yeah. Good, I can start. So we are planning the scale up quite a lot. So for now we are just keep picking up eelgrass here in Denmark, and now is, let's say, is quite manual labor based. It's like using existing equipment from farmers, using grass fields to dry the eelgrass and so on. So what we are looking at the moment is how can we, let's say, squeeze the land use even more, because that's the amazing thing about using eelgrass. We're not using very much land. We're just using land for drying, but still we are using land now. So this is something we want to decrease. And there's also some way to actually increase the amount of eelgrass, because now we are relying on the wind, we are relying on the sun and the rain to come and clean it. So now we are, let's say, building up new strategy of drying it naturally still, but in, let's say, in a more smart way. Also to be able to scale it, to be able to ship the material more smart. So we're not relying on so much manual labor and nature, even though nature is amazing. We when you need to scale, you also need to somehow be able to secure the scalability of the product. So, but in as a, I think Selena also said, is there enough seaweed and is there enough seagrass? I mean, just to here in Denmark, for example, one of our farmers has a beach and is approximately, I don't know, in yards, it's like 50 meters long. I don't know how many yards that is, but that's very not very long. But he can support us with more than 100 tons of eelgrass every year. That's eelgrass just coming to the shore. So basically, here, at least here in the coast of Denmark, we have 9,000 kilometers of coastline. Here is just less than 1 kilometer, and we can get more than 100 tons. So the scalability is there. We just need to find the right spots and the principles to pick it up. Yeah, so that's about scalability, at least from our side.
Okay, that's interesting.
I also I think about scalability a lot in terms of producing gear that is accessible, and one of the ways I've gone about that is I really want to see materials change across the industry, and I know that me having a little company on an island in the coast of Maine is not going to make that happen, but that's one of the reasons why I want to have all of the blueprints open sourced for this design, so that it takes the guesswork out of it, and that people are able to use local materials wherever they may be, to sub in for what makes most sense for them where they're growing their oysters. So, maybe they don't have Eastern white cedar, but they have some other type of material, or maybe they can't access this particular type of mesh, but they have something else that will, sub in. So that's my larger vision, is that this is something that isn't this top-down piece, but that's people can take this design and then make it their own and have it work for their specific environment and their materials that are available to them.
That's great. That's great that you're thinking that way. Actually, our most popular question is a question about how people farmed oysters before plastics, and why, like, can you not go back to that? Like, yeah, maybe you can speak about that.
That's a question I get a lot.
Yeah.
In a nutshell, let's see. In a nutshell, oysters reef, and they're previously just sort of dredged or broken off of reefs for eating. And that's why we have had mass extinctions of reefs around the world. The Chesapeake and other areas and New York Harbor, they're all trying to restore some of those reefs. but the way we eat oysters has changed. We don't eat oysters in giant, well, down in the Chesapeake, we do a little bit. So the reefing oyster isn't very conducive to feeding a lot of people. And also we've caused mass extinctions of those. Over in Asia, they've grown shellfish and seaweed in different ways using rafts. Again, they even now in Japan, they grow them in the water column, but they don't eat oysters on the half shell. They just shuck them and put them into things. And so some of this is being driven by our market. We are now used to this on the half shell oyster, which does not come from a reef, and it has a deep cup and a very particular look to it. And that really can only be done through farming, through some sort of hands-on cultivation. So unfortunately, with that change, I'm not sure which came first. It just has meant more plastic used in the industry. Not to say that there aren't other alternatives in terms of bottom culture oysters, but again, if you're trying to run a business, a lot of the mortality of the oysters through those processes is so high that it's not financially viable.
Okay,
that's a question.
Yeah, that makes sense. That makes a lot of sense, that you're really innovating like a new process, because none of the old processes make sense ecologically. Yeah. I'm sorry, Celine, did you want a moment to answer the scalability question? You partially addressed it, I think, in your presentation, that you're not trying to take over the world with algae as a foam, but it's one possible solution.
Yeah, and I truly believe in that. So for us, we're also looking into other sources for our foam, because I would love us to offer a diversity within Agripine as well. And also when we're scaling to new markets and outside of Scandinavia and Europe, I would like to supply ourselves locally. And there are places that don't have that much seaweed. So yeah, I'm a true believer in diversity and local resourcing. Yeah.
Actually, I have a question. We have a question on our side of the lab that I was wondering, this is for all of you, are there other resources from the ocean that you also see as prime potential for carbon sequestering or for ecological remediation? Have you examined other materials and arrived at the one that you want, but maybe there are other options that you think have a lot of potential for someone else to pursue?
I've been really intrigued by diatoms, and being able to use them almost as plating. I don't know if that's scalable at all, but they are just such an amazing little creature, and that they're mostly made out of silica is also very intriguing to me. It's not a fully formed thought, but I think about diatoms and I think about marine applications, and being able to do that in a laboratory setting without it feeling like an extractive use of something from the ocean, but borrowing diatoms from the ocean and growing your own and then using it.
I would probably say blue mussels is also something. I mean, we have never been looking at that, but I think that also has a great potential of. That's maybe more, let's say, it's just if you want to exchange concrete product or something that is more hard, then I mean, at least in the northern part of Europe, we have so much blue mussels, and there's quite a lot of, let's say, waste available. So let's say the scale is already there. It's just to build something out of it. But for me personally, it's only been eelgrass. I had to be quite nerdy on it from the beginning not to look at something else, because then it's going to be a detour for the development. So I will probably keep eelgrass for my life.
Nice. When you say blue mussels, you mean the shells could be ground up and used as aggregate material for compounds?
Yeah. For compounds, insulation. I mean, for basically in the building industry, for in the construction of, let's say, underneath the floor, for this cavity, or I don't know the word in English, but this layer underneath the decking, stuff like that.
Cool. Okay, one of the audience questions, this one is for Abby. Abby, you said the majority of microplastics in the ocean that you found in the ocean were from microfibers. So Molly is asking, does this mean the manufacturing process of recycled plastic bottles made into felted fabric materials for furniture, is this not a good solution? Or does this process need to be improved? Maybe you could talk about how the microfibers got into the ocean, first of all.
Yeah, this is a hard one. So microfibers make their way into the ocean through, rivers, on the water activities, runoff from land. And as we know, every time we wear or wash our synthetic clothing, it sheds thousands of microfibers. Also, when we dry them, so think about outside of your dryer catchment at your house. So those are ways that they get into our environment. And so for me, it's been a big struggle because people are it's very clever to think about ways that we can have a few more stops for plastic before it makes its way to the landfill. But what I always struggle with is that through that process and then the materials that it's put into it then is continuing to contribute to plastic pollution, whether it's plastic bottles made into polar fleeces. We know those shed a lot, or being integrated in all the composite materials for plastic wood. I forget the name of it, but like using boardwalks. And for me, I'm like, it's clever to try to find another use for this, but it's creating another environmental mess through the airborne and runoff of those recycled materials. So and it's hard. I don't want people to feel bad as what these are the options that we have. I think that what it comes down to is that we need to really look upstream, and we need to be not producing what we're producing in terms of virgin plastic. And then we won't be forced to try to think about how we could integrate these, this mountain of plastic that we have into new designs and things like that. So I don't have a flowery response to that. It's just sort of the reality of living in what I would call the plasticine. We are in a world covered in plastic, and it's really hard to avoid. But unfortunately, by continuing to use plastic and everything from building materials to our clothing, we are just perpetuating the fingerprint of pollution.
Understood. Thank you for that. I have one for an audience question for Tobias. Are you concerned that you're disturbing the natural environment by harvesting eelgrass that's washing up on the beach? When organisms wash up on the beach, they naturally cycle back into the environment. Is this a concern during the scale-up of production when you're harvesting large quantities?
Yes, of course. This probably initially it was always a concern that we are disturbing the nature, you can say, because we are collecting something that is from the nature. It's like picking leaves in a forest. Of course you're disturbing the nature somehow, but we can actually also see the positive, let's say, influence of doing it, because for example, here in Denmark we have a lot of fjords which are quite dead already. But for example, we started up picking eelgrass from a fjord in the northern part of Denmark, which were let's say the water was not visible. It was filled with algae. It was really not a nice environment. It was smelly. But then our new farmers were starting to pick up the eelgrass from the beach and slowly cleaning the beach. And actually, after a year, we can actually see that the sea and the fjord and the water was getting much more clear. So slowly, actually, we were sort of healing the marine environment because we were taking nutrients out of the water. So for me, that's a good story, because at least here in Denmark, many of the beaches is already cleaned by the municipalities. So it's already something that the municipality is doing, but they're just putting it into landfills. They're putting it into combustion or something. So here we're basically just changing the chain of the material, but potentially we can actually also clean the sea a little bit from nutrients by taking the eelgrass out of the system. And this is of course because the nature is totally stressed. There's too much nutrients in the water. So normally this should not be the case, that we need to take something out of the nature to heal it. But maybe in some areas it could actually make sense. So of course, we are thinking quite a lot about this. Let's say, is there any kind of like small animal that only lives here that we're disturbing? So this is actually also something we are looking into. So this autumn, we're actually making research together with the university to see is there any kind of a specific species or anything that we're disturbing. So making research from a beach where we're cleaning and one where we're not cleaning to see what's the difference. But it's a new, let's say, it's a new market. So it's something we are slowly learning also. Is there anything we're destroying? But let's say for now, we have the hopes high, and we can see that it's actually doing something positive. So yeah, if that's any answer.
That's great. That's good to know, and it's good that you're looking into it also. Great. This is one for all of you. This is basically about being entrepreneurs who are really pioneering a new way of making a material, a new way of building, a new way of designing. What were your first modes of investment that were critical to get you kicked off? So, and also, if you had to do it all over again, would you do it the same way or would you do it a different way? How did you start, basically, as entrepreneurs, pioneers in materials and research?
I can just speak briefly to that. It was all through grant writing. I came from a background of science and especially in the nonprofit world, and I had a lot of experience writing grants, so I was able to apply that to my vision for trying alternative materials to plastic. And luckily, I had some folks that were also intrigued by the project, and I've been pretty lucky with being able to obtain grants that have allowed me to run my business, but also do research at the same time. But there's always a need for more funding.
Yeah, I guess from my perspective, I mean, everything started, was not commercialized at any point from the beginning. I was not having any ideas to build a business. I was just totally intrigued about the material. So everything just started with soft funding, a lot of, let's say, funding from different kind of art institutions here in Denmark. So everything was starting from art and then going into more, let's say, physical experiments and quite technical experiments. So after a year, all the arts were more or less gone, and I was, let's say, in a laboratory more or less and testing. And then, yeah, and then it was like, I guess, a normal, say, tour of building a business up and seeking investors and sort of having this kind of typical journey of building up a business. But initially it was not the idea. And I think that's also a strength. I mean, at least in my case, that I was not at all interested in building any business at all. I was actually, I told myself, never going to be independent. You have to get a job to have a steady living. But yeah, and I was just in love in the material. I had to do it. So it just came out of a different perspective and then building our business. And I think that can also sometimes be good. But but slowly it became a business, and yeah, still trying to be a business, I would say. But it's a long journey, and finding investors and money and on the market can be tough, and COVID and everything. I mean, so yeah.
Okay, this is a particularly interesting question, I think, for you, Celine, because you started this research in your university and then transitioned towards like becoming an entrepreneur. So maybe, so I'd love to hear your answer.
Yeah, no, it all started with soft funding, but I must say, like, I lived off around $100,000 for 2 years, so it was not very lucrative. Like the $100,000 were for the whole 3 years. So yeah, it wasn't much money to start with, and all the investors said no. And one of the reasons for that was because I had this crazy idea. I hadn't proven much, and I was a solo founder. So if I were to do this again, I would definitely do it with a team. I don't recommend anyone doing any startup by themselves. It's no fun. So yeah, get a team, and there's so much thing I would do differently. Yeah, Probably long stories, but yeah, it started with soft funding. We got our first investment in 2024, and yeah, that's sort of that kicked things off, I would say, when we got the first investment. But I think for me, like standing in the 3 years without any kind of investment were all about having fun with your work. I thought every day going to work was fun, and I remember like there were periods where I was looking at like job postings to see if maybe I should do something else because I can't even do my phone bill. But I couldn't find myself doing something else because nothing were as fun as my own job. So I think for me it was important to enjoy the journey and what I was working with. Yeah.
That's great. Yeah. And it seems like you have been enjoying it. Actually, I have a follow-up question for you, Celine. Unrelated, actually, but we have a question from an audience member asking if there are other applications besides upholstery foam that you are thinking about for your product. And also if you've tested agoprene as a thermal insulation material for buildings. So maybe you could talk about other possible applications, what you've tested for.
Mm. We have not tested it, but we have sent samples to companies that have done some testing. But we have not tested it ourselves. So there's no like certification on that area. But we're definitely looking into building insulation for the future. Right now we just need to scale up, and then we can look into new markets. For us, it's been it's been some limitations in the production facilities, as you already seen pictures of. So yeah, we've been mainly focused on the furniture industry, but it doesn't mean that the foam can't be used for other things. We have tested it for handbags, foam in bras. We have tested it for insoles, shoe padding. And also sent some samples to the automotive industry for seating applications there, but also the interior around the car. Headsets, like foam is everywhere. It's crazy. So for me, it's like I want to go into all these markets. I think it's super, super interesting, and I don't want to sort of put like a limit on our foam. But right now we've only like entered the furniture industry, but hope to test other markets soon.
Yeah, that makes sense. I mean, the furniture foam industry is massive, and
Yeah.
you got to choose. You got to choose in the beginning, especially. Okay, we'll have one more question, and then I think we'll call it. So this one is for Tobias. This is another eelgrass related eco question. So first of all, Martha says you are developing beautiful materials. There seems to be an abundance of eelgrass in Denmark, which you addressed in a previous question. But in other parts of the world, many of the eelgrass meadows are suffering from a variety of environmental stressors, and there are initiatives to replant. Are you concerned that the success of eelgrass materials could lead to overharvesting in other parts of the world from already fragile ecosystems?
No, I would say that because I mean we're not harvesting anything. I think that's really important to state because we are actually collecting on the beach, so we're never going to disturb any eelgrass meadows at all. We're actually just giving, let's say, more oxygen for the sea because we're taking nutrients out. So I'm not. I mean, if we should let's say take everything that goes to the beach and use it for our material, that's not a problem according to the existing eelgrass meadows. It's more a question of is there any small bug or anything on the beach that suffers if we take it out from the beach. So it's more on the land that could be something. And of course, eelgrass normally has a long journey before it comes to the beach. Normally it comes to the beach and it goes to another beach. So I mean, it decays or also in the water. So by capturing, we are actually, let's say, preventing a lot of things to happen. But of course, this is the same line with the research we're doing in the autumn here to look into what is there anything that we haven't looked at that could be a potential danger for the scale up of the material, and is it something we have to do differently? For example, at the moment we're also looking at, for example, we have a lot of heat plants here in Denmark which are cooled down by seawater, and here they are already taking a lot of eelgrass away from this. So finding places where we need to take the eelgrass away could be a potential of scaling up instead of taking it away from the beaches, for example. So I think there's plenty of areas where we can look into where we need to pick up the eelgrass, arbors, different kind of places where you don't want the eelgrass to be, and where there's no biodiversity or anything to disturb. So yeah, of course, I'm always concerned about when you read something that is in decay, something or anything, because that's the thing in Denmark. We have too much land use. We are putting too much nutrients in the water. So in Denmark, the eelgrass is decaying. So that's of course a huge problem, and also something we talk about every week at the office. But we can see that you can actually get it back. So I think that's the positive side of the story.
Okay, great. Do any of the other speakers fear success in terms of like the materials that they're using, becoming like switching from becoming a positive to potentially having some negative attributes, or should we just leave it here?
I mean,
Okay.
yeah,
Okay.
I'll just say that like everything has a cost, and you have to weigh up what those costs are, and then think short, medium, and long term, and what we want that future to look like.
Great. Well, I thank you again. This was a super interesting talk. It's interesting to hear all the different ways that you're approaching your research and your work. And thank you to all of these attendees. Thank you, Abby, Tobias, and Celine, for being so generous with your time and expertise. And thank you to the Friends of Healthy Materials for their generous support, which makes events like these possible. And if you are in New York on April 28th, please join us for our next in-person event, From Field to Form, Cork, with the Architectural League of New York. And thank you all again for coming. Thank you, thank you, thank you.